Hello, and today I'll be showing you how to effectively compress volumetric data of any type. For this example, I've chosen a sparse billowy smoke preset from the shelf tool. So this is the import from the DOP network, and we can see we have two different volumes, one a float and one a vector. So the first thing you would like to do is always convert your volumes from native Houdini volumes to VDB volumes. So the way you can determine that is the native volumes are light orange and VDBs are light red. So VDB convert, like so. Actually disconnect that and convert that to VDBs, like so. VDBs are much more optimized, or if that makes sense. So what I want to do now is place a VDB merge, sorry, not VDB merge, but scalar to or vector to scalar, and the reason is I want to combine. Now we can see that we have three different velocity fields, which are all scalar or float, and I want to convert them into a one vector field, like so. You can see also up here how it's done. It's taking all the names, or which have behind that .x or .y, .z, and then combining them all together. That's how it's done. So then what we want to place is a primitive property, and I always do this on all my volumes, and I always do that with all data in Houdini, and I convert them into a 16-bit float. The next thing I want to do is place a VDB clip. So this will be very efficient if you already have a camera setup like I do have here. And what I can specify here is based on camera, where I'm going to copy the camera, and this will cut the voxels which are not in the camera view, as you can see, like so, reducing the file size. Of course, you want to do this if you're doing it for rendering most of the time, or caching it just for rendering, because if you're going to be then using, let's say, the velocity field in other simulations, you should always keep the entire velocity field, not just the one in the camera view. But I think it's good to mention that you can VDB clip. And now, if we check the comparison, we can see that it has 11.5 megabytes almost, and now after compression, it's going to be just 4.8 megabytes, which is significantly smaller. One thing I actually forgot is we can always resample our velocities. Generally speaking, most of the times you want to resample your velocity. You don't need such precision in your velocity either, so it's not something to be worried. You're not losing any detail. Now if I can save it again, we can see it's only 0.969, which is a lot. Just considering that the velocity is a vector field, that's like 3 density fields essentially, and you're just increasing the voxel size by 2, or multiplying it by 2, which is going to reduce the size a lot. Another additional thing, which most of the times in post-simulation scenarios you won't use, but let's say you have certain like volumes you created in Houdini, you can use a volume VOP, or volume wrangle, or a volume VOP would also work. And in here, you're going to set a inf function, and in this case, I'll just use it on a density, but you can use it on all fields, it doesn't matter. And if channel float, I'll place a threshold, then execute following. So if something under this threshold, then set density to 0. I'll set the threshold to something higher, in this case like 0.05. And now we want to remove the voxels which are at 0. So what we can do is place a VDB activate to remove the voxels, so to deactivate them. And now if you can see we had 177,000 voxels, and suddenly we only have 154, which if I save this to disk, removed some of the data. If I check it correctly, if I remove this, we have 969, and after the compression, we saved just a little bit of data, which is always nice to do. Of course, the reason why you won't do this in most scenarios is because in the solver itself, let me go inside the solver, you have this clamp below, which will always set if the density is below this value, it will be automatically set to 0, because why compute something which doesn't have any effect on the resulting simulation? So yeah, I hope you learned something new, and I'll see you again. Bye.